Marimar is made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydel online class. So today we want to look at probability without replacement. So in our previous video, I've actually made a video on probability with replacement. So under probability with replacement, if you picked like 10 times, it retains its value, because when you make the first pick, you will replace before you take the second one. But in this case now, when you picked, you don't replace before you pick the next one. So there is a slight difference between probability with replacement and probability without replacement. So let's give the same example that we used the other time. That same example under probability with replacement, so that we'll be able to see the effect of this. Where we have a bag contains 5 blue balls, 6 red balls, and 4 green balls. That's what we have. So if 3 balls are chosen or taken at random without replacement, because someone says find the probability that the first question, there are 2 reds and 1 blue ball. The second question, that all the 3 balls are 3 green. There are 3 green balls. All the 3 balls are 3. Then C, they are of the same color. They are of the same color. Then the last question is that they are of different color. They are of different color. They are of different color. Okay, that is the question. And we've actually solved this question using probability with replacement. So this is the ball: blue, red, and green. 4 green balls in that bag, 5 blue and 6 red. So we've solved this problem using probability with replacement. So now let's see the effect of probability without replacement. Of course, if you are given this question, you list out what you are given in order to know the probability. Blue balls that we have here, they have just 5. Green, 4. Then red, 6. So the total is 15. So once we know the total, we can actually know the probability. What's the probability of blue balls? Will be 5 all over 15. So probability of green ball will be 4 all over 15, while probability of red ball will be 6 all over 15. So this is the first step that we're going to take before we now go ahead and look at the effect of taking a ball without replacement. So this question is actually question under probability without replacement. We want to find when we take 2 red balls and 1 blue. Then when we have 3 green balls, then when all the balls are of the same color and when they are of different color. So those are the 4 questions that we want to find. So we start with the first one. Let's start with the first one and see the effect or the implication when we have without replacement. Okay, this first one now, we are looking for probability that if the 3 balls are taken at random, 2 are red and 1 is blue. So what is the effect? Of course, this is what you do. If 2 are red, simply means we can have red, blue, or red, blue, red, or blue, red, red. And of course, if this is the case, we are still going to get the same thing because they keep reducing by 1. This is what I'm saying. After this, I'll just let me use this to let me explain with this. But after this, I'll just go ahead and solve the problem. This is what I'm saying. If you pick the first ball and it is red, what is the probability of red? 6 all over 15. Multiply by, you have picked 1 out of the 6 red ball. Then it will affect the total 1 after the 15. So you pick the first ball, you don't replace. You are left with 5 red. Then the total has been affected. It has reduced to 14. So if you are picking another ball now and it is red, you are picking from the remaining 5 all over the remaining 14. So this is the effect of probability without replacement. So that is the total is 14 now. Then if you want to pick another ball, you've picked 2 balls now without replacement. The total has been affected, reduced to 13. So you are not picking from the remaining 13. So if you go ahead now and pick the ball, if the ball is blue, now, you are picking from the 5 blue. That will be 5 all over the remaining 13. Or is plus. Or if that's not the arrangement, you decide to pick the first ball. It's red. Red is 6 all over 15. Multiply by. Once you pick 1 out of the 6 red balls, you are left with 5 here. Then the total will be 14. So if you now to pick the second ball and you pick the second ball is blue, you are picking out of the 5 blue that we have all over the total has been affected because you've picked 1 red ball that you didn't replace. So the total has been affected. The remaining total is now 14. Multiply by, if you now want to pick another ball and that ball is red, you've taken 1, which is 60. If out of 6, you've taken 1, you didn't replace. So we are not picking from the remaining 5. We are going to have 5 all over 13. Or is plus. If this is the arrangement, the first ball you pick is blue, that will be 5 all over 15. Multiply by, you now want to pick the next ball. We are picking out of the remaining 6 all over. You've picked 1 blue ball that you didn't replace. The total has been reduced to 14. Multiply by, when you pick this, out of the 6, you pick 1. You are left with 5 since you did not replace. Then if you have to pick another ball and it's red, you are picking from the remaining 5 all over 13. Because when you picked, you didn't replace. So this is what we have. Look at the numerator, we have 655, 655, 565. The numerator is 14, 13, 14, 15, 14, 13. So I can just say 3 multiplied by pick any of these. You get the same answer. That will be 6 over 15 multiplied by 5 over 14 multiplied by 5 over 13. It's still the same thing instead of doing everything in that order. 5 here 1, 5 here is actually 3. 3 can take care of this. Okay, so that at the end of the day, we have, at the end of the day, if you multiply, if you do your cancellation very well, then we can actually get 2 here is 3, 2 here is 7. We're going to have 15 all over 91 as the probability. When we pick the ball and it's without replacement. Then the second question, when you pick the ball and everything is green, it is green, green, green. When you pick the third ball and everything is green, it simply means that when you pick the first ball, you are picking from the 4 all over 15. Multiply by, you pick the first ball, you didn't replace. The green ball will be left with 3. We are left with 3 in that bag. So if you are picking the second ball, you are picking out of the remaining 3. That will be 3 all over 14. Multiply by, you've picked 2 green balls now. You did not replace. You are left with 2. So if you have to pick the third ball, you are picking from the remaining 2 that you have there all over 13. The total has also been affected. And that's what you're going to get. 3 here 1, 3 here is 5. 2 here is 2, 2 here is 7. At the end of the day, we're going to get 4 all over 455. And that's what we are going to get. So I want us to see the implication of probability without replacement. When you take and you don't replace, it's going to affect that color and it's going to affect the total. But under probability with replacement, once you take, you replace before you take the second one. And that is the difference between probability with replacement and probability without replacement. So I want us to note, let's note that. You just have to note that. So let's note that. Then the third one, the probability that they are of the same color. the same color. So in this case, either we have blue, 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 or you pick green, 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 or you pick red, red, red. Of course, it's going to still see the same thing. What's the probability of blue? The first blue will be 5 all over 15. You are picking from the 5. Multiply by when you pick the second one, you are picking from 4 all over 14. Then when you pick the third one, you are picking from the remaining 3 all over 13. Or is plus. Then green, 4 all over 15. The second one, you are picking from the remaining 3 all over 14. Then you are picking from the remaining 2 all over 13. Plus, when you come to red, 6 all over 15, that's the first ball. The second one is 5 all over 14. Then 4 all over 13. That's what you are going to have. So if you solve this, if you look at it, at the end of the day, for the blue ball, if you do your cancellation correctly, you're going to have 2. Here 1, here 3. 3 cancel 3, here 2, here 7. We're going to have 2 all over 91. Plus, for the green balls, we've gotten the value of that as 4 all over 455. Then plus, for the red ball, we're going to have 3 here 2, 3 here 5. 5 cancel 5. Here 2, here 7. We're going to have 4 all over 91. So if you actually find the total here, at the end of the day, we are going to have 34 all over 455. If you find the LCM and you do your cancellation, that is what you are going to get. So this is the probability of picking the same color under without replacement. Then the last one is when they have different color. Different color. That's the last question. When they have of different color. Of course, if you check my video on probability with replacement, it's still the same thing. Just that the value keep reducing. In this case, under without replacement. So you can have red, blue, green, or blue, green, everything multiplied by 6. Because if you have different color, you can first pick red, blue, green, red, green, blue, or you pick blue, red, green, blue, green, red, or you pick red, blue, green, red, green, blue. So everything will be, you must pick all the 3, then multiply by 6. If you don't want to stress yourself, that will be 6 into bracket. If you pick the first one and it is red, it will be 6 all over 15. Multiply by, if you pick the second one and it is blue, you are picking 5 from the remaining 14. Multiply by, if you pick the next ball and it is green, you are picking 4 all over 13. Because in this case now, it's only the total that will be affected. It's only the total that will be affected because you are picking different balls. So 3 here is 2, 3 here is 5. 5 can actually take care of 5. 2 here is 2, 2 here is actually 7. At the end of the day, if you do our cancellation correctly, you are going to have 2 times 2, 4, 4 times 6, 24, all over 91. And that's what you are going to get. So that is what we are going to get under probability with replacement. But under probability with replacement, we actually have another method we can use. We can actually use combinatorial analysis using the combination method. So if you don't want to follow this process, there's another process we can use. So we can actually use another process. So it's called the combinatorial approach for probability without replacement. That is, I'm going to use the knowledge of combination to be able to solve this problem. So I'm going to do that now. Alternatively, if I don't want to follow all the steps that I've been doing now, I'll say alternatively, we can solve this problem using combination approach. We call it combinatorial approach. So what do I mean by that? I'll go back to the question A, where we have probability that the ball, we have 2 reds and one blue. So what do I do? Please, you can check my video on permutation and combination so that you know the formula to find permutation and combination. Just check my video on permutation and combination. Then you also check my video on you also check my video where we have binomial theorem. So the 2 videos will actually help you to know what I'm about to do here. So in this case now, if I want to find out of the 15 balls, I want to find 2 that the 3 balls are taken without replacement. We can only use this method when we have without replacement. When we have with replacement, we cannot use this method. So if we have without replacement, this is what we are going to do. So these two red balls that we're taking, they are taken from the 6 that we have. That will be 6. That will be 6 combination 2 multiplied by this one ball. We are taking it from the 5 balls that we have. That will be 5 combination 1. Then what is the total? The total is 15 combination 3. Because 3 balls are taken out of the 15 that you have in the bag. 3 balls are taken out of the 15 that you have in the bag. Then out of that 15 that you have in the bag, 3 balls are taken. So what is the effect of those 3 balls? That's what we are trying to say here. That's what we are trying to say here. And if that is the case, this is what you get. So of course, for combination, this is what you get. We say 6 combination 2 is 6 factorial all over 6 minus 2 factorial. That is 4 factorial, 2 factorial. Then multiply by 5 combination 1 will be 5 factorial all over 5 minus 1 factorial. That's 4 factorial, 1 factorial. Then divided by 15 combination 3 will be 15 factorial all over 15 minus 3. That's 12 factorial, 3 factorial. That's what we are going to get. So please, for you to be able to understand this concept, check my videos on permutation and combination and binomial theorem. Then in this case, I'm going to have, I can reduce 6 to 6 times 5 times 4 factorial, because I'm going to do some cancellation now. All over 4 factorial multiplied by 2 factorial is 2. Multiplied by 5 times 4 factorial all over 4 factorial. 1 factorial is 1. Then here, if I want to change division to multiplication, I will interchange. I'm going to have 12 factorial all over 3 times 2 times 1 all over 15 factorial is 15 times 14 times 13 times 12 factorial. So we do some cancellation now. 4 factorial will cancel 4 factorial. 4 factorial will cancel 4 factorial. 12 factorial will cancel 12 factorial. At the end of the day, we'll be left with, what do we have at the denominator? I have 15 here. So what I can do is that 2 can actually cancel 2. Then I have 5 here. 5 here 1. 5 here is actually 3. 3 will cancel 3. What else do I have? I have 6 here. I have 6 here. So 6 here. 2 here is 3. 2 here is 7. At the end of the day, I have 3 times 5 at the denominator, which is 15, all over 7 times 13, which is 91. And that's the answer. So if you compare this with the answer we got when we use the normal probability approach, it's the same thing. So we can actually use this to solve all the problem. So that's that about the first question. That's that about the first question. We go ahead and solve the second one, where we have the probability that all the 3 balls are green. So what would that give us? When all the 3 balls are green, what is the implication? It will just be, if you want to use this approach, that will be, how many green balls we have? 4. 4 combination 3 divided by, we are taking the 3 from 15 combination 3. That's what you're going to get. And if you do that correctly, I'm going to have 4 factorial all over 4 minus 3. That is 1 factorial, 3 factorial, divided by 15 factorial all over 15 minus 3. That's 12 factorial, 3 factorial. So what do we do here? For us to be able to get all this combination method, I've said that you check my video on permutation and combination and theory of and binomial theorem. I will have 4 times 3 factorial. Factorial simply means you reduce by 1. All over 3 factorial. 1 factorial is 1. Multiply by 12 factorial, but 3 times 2 times 1. That's the meaning of factorial. Then I will have 15 times 14 times 13 times 12 factorial. If you want to stop, you just stop where we can cancel. So 3 factorial, we cancel 3 factorial. Then here, I have 2 here is 2. 2 here is actually 7. 3 here is 1. 3 here is actually 5. At the end of the day, we have 2 times 2 at the numerator, that is 4. Then we have 5 times 7. At the end of the day, we are going to have 4 all over 4, 4, 5. And that is what we actually get at that previous example. That's actually our solution. So we go to the third one, where we are, when we have, they are of same color. The probability that they are of same color. Under this same color now, this is what we do. You know, we are dealing with probability without replacement. So if they are of the same color, then if the probability is, we have 6 combination 3 all over 15 combination 3, or this when they are red, When they are blue, 5 combination 3 all over 15 combination 3. Or when they are green, 4. There are 4 green blocks, 4 combination 3 all over 15 combination 3. So that's what we are going to get. So if we do that, if we actually do that, then what do we get? You know, this is what we are going to do. This is what we are going to get. This is what we are going to get. We are going to have, in this case now, we have 6 combination 3. That will be 6 factorial all over 6 minus 3, 3 factorial, 3 factorial. Okay. I can actually divide everything. I can go ahead and divide everything because everything is divided by the same thing. I'll say plus 5 combination 3 will be 5 factorial all over 5 minus 3. That is 2 factorial, 3 factorial. Plus 4 combination 3 is 4 factorial all over 1 factorial all over 1 factorial, 3 factorial. Everything now divided by 15 factorial all over 15. That's 12 factorial, 3 factorial. That's what I'm going to get. I can actually combine everything. So from here, I'm going to have 6 times 5 times 4 times 3 factorial all over 3 factorial. Multiplied by 3 factorial simply means 3 times 2 until you get to 1. That's 3 times 2. This will cancel this. This is going to cancel. We cancel this. I will have 5 times 4 plus I'll come to the here 5 times 4 times 3 factorial all over 2 multiplied by 3 factorial. This will actually cancel this. 2 here 1, 2 here 2. So I'm going to have 5 times 4, I have 20 here. I have 5 times 2, I have 10 here. Plus, I'll come to this side. 4 times 3 factorial all over 3 factorial times 1. This will cancel this. I'm going to have 4. That's what I'm going to have inside that bracket. I will change this to multiplication. So I will have 12 factorial 3 times 2 all over 15 times 14 times 13 times 12 factorial. 12 factorial will cancel 12 factorial. 2 here 1, 2 here 7, 3 here 1, 3 here 5. At the end of the day, I'm going to have, this is what I'll get to. 4 times 5 is, I'll have 20 plus 5 times 2, 10 plus 4. Everything all over. I've done all the cancellation. I will have everything to be equal to 5 times 7. So I'm going to have 5 times 7 there. So I will have 5 times 7 times 13, and that will be 455. So the final answer will now be 34 all over 455. You can actually compare this with the one that we actually have when we use the normal probability approach. Then the last one, which is D, is when they have different colors. Where they have different color, it's still the same thing. It's still the same thing. When they have different colors, we only pick it once. That is, when they have different color, we are going to have, this is what we are going to have. We are going to have, out of the red, you pick 1 from the red, multiply by from the blue, you pick 1, then from the green, you pick 1. Everything all over, we are picking 3 from the total, all over 15 combination 3. This is what we get. So what do we do here? What do we do here? We just say, 6 factorial over 6 minus 1, that is 5 factorial, 1 factorial, 5 factorial, 1 factorial, multiply by 5 factorial all over 4 factorial, 1 factorial, multiply by 4 factorial all over 3 factorial, 1 factorial. Then everything at the numerator divided by 15 factorial all over 12 factorial, 3 factorial. So here, I'm going to have 6 times 5 factorial all over 5 factorial, multiply by 5 times 4 factorial all over 4 factorial, multiply by 4 times 3 factorial all over 3 factorial. That's what I'm going to get here. Then multiply by 12 factorial, multiply by 3 times 2 times 1 all over 15 times 14 times 13 times 12 factorial. 12 factorial will cancel 12 factorial. This will cancel this, this cancel this, this cancel this. At the end of the day, we have 5 times 6 times 5. We have 6 times 5 times 4. And that will actually be 120. We're going to have 120 there. So 3 here 1, 3 here is actually 5, 7. So at the end of the day, we are going to have 5 will take care of 5. 5 will take care of 5. We are going to have 6 times 4, that's 24. We are going to have 24 all over 7 times 13, 91, which is the same thing as what we got when we use the normal probability approach. So if you can, we should note that when we have probability without replacement, we can actually use this approach. For us to be able to use this approach, we must understand combination very well. So you can actually check my video on permutation and combination, so that you know the meaning of this combination and you know the meaning of factorial. So I would love to stop here because of our time. We are going to continue from there in our next class. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target